Hello everyone, Mr. here, and today we're going to be solving a different sort of puzzle, which I believe will be beneficial for both solvers and setters. Unlike normal puzzles, this type of puzzle has no solution, and it's your job to prove that it has no solution, to show that the clues themselves indicate that the clues are in fact impossible. I will quickly go over the rules to each of these puzzles, and then I will give you a moment where you can pause the video and work out why there is no solution here. Then I will go through each of the exercises and show you why there is no solution, and I believe these exercises are very valuable for developing your skill as a solver and as a setter. In particular, I think the setting skills that you acquire from these type of exercises are invaluable. They give you a better sense of when your puzzle looks broken or feels broken. It's almost like a spidey sense. The first of these we will go through is this one by Tyrgannus. So in this puzzle Tyrgannus has provided us, we have killer cages, and of course this is Sudoku. We'll be trying to mainly stick to Sudoku. Remember that killer cages simply sum to the number given in the top left corner. So these two cells sum to 6, these two cells sum to 14, these two cells sum to 15. For example, I could put a 7 and an 8 in here. 7 plus 8 is 15. You could also do 6 and 9. These could be in either order, but you just need to put the digits in there that sum to that total. Now I'll give you a moment, or you can pause the video and work out why this puzzle has no solutions. Now I need to work out why it has no solutions. Oh, that's very cute. That's very cute. Did you see it? It's quite cute. So it hinges on a few different ideas. The first of which involves a 5 and a 6 cage, and a 14 and a 15 cage. So the idea is that if the 5 cage was a 1-4, then this 6 cage couldn't be a 1-5 and it couldn't be a 2-4. Therefore, it would have no fill. So this 5 cage would have to be a 2-3 cage. Similarly, this 15 cage can't be 6-9, because then this couldn't be filled with 6-8 or 5-9, so therefore this would have to be a 7-8, which leaves one option for both the 6 cage and the 14 cage, but both options, which they must now be, involve 5. This must be a 1-5 and this must be a 5-9. And there we go, we have proved that this has no solutions because there would be 2 5s in row 1. That's a good example of a no solutions puzzle. Did you get it? Comment below if you did and how long it took you. Which one should we look at next? We have this Little Killer by Jovial. Little Killer is similar to Killer in that we're summing to a certain number. We're summing to 11 in this case. So these 5 cells along this diagonal must sum to 11. In this case, these cells must sum to 11 as well. I will highlight both of these to make it slightly easier to see what might be going on. And digits can repeat on these diagonals as well. And I will allow you a moment to work out for yourself why this has no solutions. Have you figured it out yet? I just figured it out. Alright, so let's start with this blue diagonal. It's clearly the longer of the two, so we should start with that one. And we might notice that if we put the minimum into here, 1 and 2, the minimum into here, 1 and 2, and the minimum into here, 1 and 2, then we will get to 3 plus 3 plus 3 is 9, plus double 1 will be exactly 11. But now, these can't be 1s because they're in the same box as this one. these can't be 1s because they're in the same box as this one. And this sees the 1 in the row. Therefore, there are no 1s on any of these cells. So now the minimum we can do in these two cells and these two cells would be 5 and 5, but the minimum we can put here is a 2. And this adds to 5 plus 5 plus 2, which is 12, not 11. Therefore, this has no solutions because by minimizing this diagonal, we have locked 1 out of any of these cells and we cannot make 11 in these 5 cells anymore. Since it's just not minimized enough, it's going to be a 2 leading to 12 instead of 11. Very cute puzzle from Jovial. Alright, let's move on to Nordy's German Whisper puzzle, where we have these green lines in these square formations in the top 3 boxes. These German Whisper lines mean that adjacent digits along the line must have a difference of 5. For example, if I were to put a 1 here, then these two cells could be, say, 6 and 7. Those would be a difference of 5, but they couldn't be 5 and 4 because 5 and 1 have a difference of 4, and 4 and 1 have a difference of 3. We need a difference of at least 5. Notably, German Whispers have this property of oscillation. So if I were to put low digits in these cells, then these cells would be high digits. It sort of has to oscillate low, high, low, high. And as well, you can never put a 5 on a German Whispers line because then the digits next to it would have to be either 10 or 0. I will give you a moment to figure out the reason why this whisper puzzle has no solutions. Feel free to pause the video if it takes you longer than a few moments. Let's see if I have figured this out. Alright, so one thing I do know that I didn't mention is that I can never put a 4 on one of these. And this isn't a general property of German Whispers like the 5 was. Instead, this is a special property when we have sections of the German Whisper which are within a box. So if I were to put a 4 here, the only digit in the digits 1 to 9 that is able to go on a German Whispers line next to 4 is 9. But I can't do that. So the 4 and also the 6, which will have double 1, cannot go on any of these cells. So 4, 5, and 6 are all not on these cells. So where do the 4, 5, and 6 go in row 1 and row 2? Well, they go in these cells. In row 1 and row 2, the 3 and the 7 have to be on these lines. But the 3 and the 7 can never be next to each other on a German Whispers. So therefore, since I can't have something like this, because then these cells would have no value, I can't put a 3 and a 7 on the same German Whispers, so I can't put 2 3s and 2 7s into rows 1 and 2. I just can't do it, because I can choose 2 of these German Whisper lines to have 3s on, but then I only have 1 left over to put 7 on, and I can't double 7 in the box. I can't do double 7, even Sven does not like that. So comment below if you were able to get this one. This one took me quite a while to realize, so don't feel too bad if you were unable to realize it as well. Alright, let's move on to Perladel's no solution thermo consecutive pairs. The nature of a consecutive dot is that the digits across it have to have a difference of 1. So if this is a 1, this will have to be a 2. If this is an 8, this could be a 7 or a 9, for example. The digits across here just have to have a difference of 1. Thermometer has to increase from the bulb, which is this circle, to the tip, which is this end. So on this particular thermometer, we could do 1, 2, 3, 5, 6, 7, 8, 9. I will let you figure it out. Feel free to pause the video if you need to, and rejoin me in a moment. Alright, if you figured this one out, comment below, let me know how fast you did it. Yeah, that is really cool, actually. Let's consider this puzzle without the dot. Let's start there, right? Let's start there. If we didn't have this dot, what would we have to do to fill these two thermos out? Well, if I put a 1 here, I've automatically made this a 2. I've made it a 2 right away, which means that this entire thermo will be forced to do that. And you might notice already an issue. This is a 9, so we can't put a 9 here. So this has to be 8, 7, 6, 5, 4, 3, 2. But this dot requires that the break in this consecutiveness of the thermo appear in this set of 3 digits. And therefore, we cannot fulfill it. It must have no solutions, which is a beautiful idea. A very beautiful idea. It was a little bit trickier than I thought it was, actually. All right, let's move on to 2/10ths. I believe this is a alternate version of his puzzle Graviton, which he did with Tallcat. And I believe 2/10th was the one who made the break-in for this, and I know this because I interviewed 2/10th the other week. You can check that out, link in the cards. But this uses lockout lines and these even cells. So in the squares, these little gray squares, we have to put even digits, so 2, 4, 6, or 8. So I'm just going to label those up to make it easier for you guys. And these lockout lines are kind of like between lines, but the opposite. So any digit that goes on here must not be equal to or between these diamonds at the end. So let's take an example. So if we do a 1 and a 6, for example, then these cells cannot be the digits between 1 and 6, which are 2, 3, 4, and 5. They would have to be 7, 8, and 9. And you can already see there's a little issue there. The other part of lockout lines is that the digits at the ends have to be at least 4 different. So I couldn't put, for example, a 1 and a 2 here because 1 and 2 are not 4 apart. It's a bit like the whispers constraint where they have to be 5 apart, but in this case, they have to be 4 apart. So see if you can work out why there is an issue and there is no solution to this puzzle, and I'll see you back in one moment. All right, figured it out? Okay, perfect. Good job. Let's start with this. So, what digit can I put here that will allow me to put 4 digits on this line? Well, think about a lockout line and the minimum distance between 2 numbers, okay? So, for example, let's take 4 and 8, for example. So, if this was a 4 and this was an 8, then that would be the minimum distance. That would be a difference of 4. A difference of 4 is exactly what we need to put 4 digits on the line. This allows us to put 1, 3, and 9 onto here. Any greater distance, so if I put a 9 in here, for example, then these cells will only have 3 options. So 4 digits is actually the maximum that you can have on a lockout line at any time. So all of these cells, which are attached to these, must have the maximum difference. So, for example, 4 pairs with 8, and 2 pairs with 6. So these are all even digits, just like these ones. But now, if I tried to pair, let's just say these are the 4, 8, right? The 4 goes with the 8, so then this will not be a 4, 8. So this will be a 2, 6. So then this will not be a 2-6 because there's a 2-6 pair in this column. So that will be a 4-8. So this will be a 4-8, and this will be a 2-6. So it'll look like either this or all this rotated. But either way it's fine. And the point is that on a 4-8, you're going to need 1, 3, and 9. But on this 4-8, you're also going to need 1, 2, 3, and 9. So both of these have 2 in them. So both of these will be 6. Which I thought would break immediately, but apparently not. Okay, 2 to 6 has 1, 7, 8, and 9. Which means that both of these will be 4s, and both of these will be 8s. And all we need to do is look at these 4 corner-looking cells and ask what value can go in them. Well, for example, row 2, column 2 cannot be 1, 2, 3, 4, 7, 8, or 9, or 6. So the only value it has is 5. Similarly, here, 1, 2, 3, 9, 8, 7, 6, 4. So it's a 5. But that would place 2 5s in row 2, and in fact, all of these cells are 5. So that will not work, and this puzzle has no solutions. That one was definitely more tricky than the others. Please comment if you did get that one and how long it took you. Let's move over to a jovial puzzle in which she used classic Sudoku rules for a no solutions, which is fun. Let's take a look at this. I'll let you figure it out. Give you a moment. I thought this puzzle looked familiar, but it is not. Which means that I have no clue what the solution is. Okay, now I'm lost. Is this just a classic Sudoku? Are you trolling me right now, Jovi? Just gives me a classic Sudoku that's actually solvable. Honestly, she would do that. 9s in here, let's just pencil work. I don't know. Something's going on. Hopefully something's going on, or is it to do with the 4s? Should have given more time to figure this one out for you guys. I'm worried I made everyone feel bad. There's 6s down here when I've just asked you to solve a classic Sudoku that has a solution, I think. That Joby has trolled me with. I swear if this has a solution. I was gonna check them, but I didn't. That's my fault. I get pranked. What? I don't understand. It's gotta be something simple. Why does this have no solutions? Row 3 looks slightly congested. 1 in row 3 has only 2 places to go. Oh wait, that's the same 2 places as 2, because that can't be a 2 either, which is totally obvious from this and this. So that's a 1-2 pair, which means this is a 3, 4, 8, and there's no 4 there. So that is a 4, weirdly. So there's a 4 in one of these two. This is a 3, 8. So now there's a Jovi wing on 8s, which puts an 8 down here, which I can't pencil mark because classic people don't like that. Don't like progress. They don't like fun. Which is fun. It's not interesting. It's just not. It's not interesting. What have you given me? What is this? What the hell is this? Let's ask Joby. I give up. I give up.
Hi, this is Jovial. I wanted to show the intended way to view my No Solutions puzzle. Sorry, Mem, for giving you a lot of grief with this, but I wanted to come on and quickly demonstrate what I was thinking when I made this. So as you might have suspected, this is based around an exoset. Namely, these are our cross lines here, and then we have one that can only appear in 2 rows. I will color that. I will color those red. We have 2 as well. We have 3. And we have 4. I misclicked there. We'll do blue and yellow here. So that means we have to have all of the digits 1, 2, 3, and 4 appearing in these 5 cells. I'll color them gray. So we have at least 1, 1, at least 1, 2, at least 1, 3, and at least 1, 4 here. So these 2 cells here, C5, 6, 7, 8, and 9, so they are from 1, 2, 3, 4. And because they are from 1, 2, 3, 4, they must appear in gray somewhere. So this cell sees all 4 of these, so it must appear in this cell, and likewise with this cell. So this cell is now limited. It must be both of these digits, which of course is impossible. Another way you could view this is through set equivalence theory, which I imagine a lot of you will find a little bit easier because you're more familiar with it. We can go ahead and subtract these like this. So green is 4 houses and pink is 3. So we have to have 1, 2, 3, 4 appearing in each of these cells as well at least once. And then of course we have the same problem as before.